Okay, so the next question is, how long will it take for it to come to a stop in terms of the time? So let's move on. E, F, G, I think this is G. Time it's going to take for it to come to a stop. Okay, once again, I'm going to copy this. I think this was already copied. Okay, T is what I want. We got T here, we got T here. Guys, we know the acceleration, we know the initial speed. We know the final speed. This is perfectly okay, so we can use this. We can also use this if you want to. Okay, we know the distance, which is this. We know the initial speed, that's 60 miles per hour. We know the acceleration, so you can solve for T, except the problem is it's a quadratic equation. This one is going to require the quadratic formula. It's perfectly fine, except this one is easier. Okay, so I like that one. All right, so let's use this. All right, so final speed is going to be 0. So you got initial speed plus a times t. All right, what do we sum for? We are sum for t. Okay, so get rid of the L. And so we got a times t. Get rid of a. And here's the final speed. Here's the time at the final speed. All right, then now the numbers. Initial speed is 26.78 or 79. And acceleration is still negative 8.5. All right, so what do we get in terms of time? Okay, so Jack, give yourself 5 points for that one. It's going to take about 3 seconds. All right, so this is going to be about 3 seconds. Wiggle 3 seconds. Okay. It's about 3 seconds, 140 feet. So it'll come to a stop within 3 seconds. The car comes to a stop within 3 seconds within 140 feet, right? How about the truck? What is the acceleration of the truck? Do you guys notice that the truck is the same acceleration as the car? So what that means is if it takes 140 feet for the car to come to a stop, truck is also going to take 140 feet. It's the same acceleration. Truck also going to take about 3 seconds to come to a stop. Everything is going to be exactly identical. It's weird. You guys didn't expect that at all. It's very counterintuitive, but actually it's not. Even intuitively, this result is going to make sense to you guys. Okay, number one, how do we know that? Guys, imagine that you're driving in a 30 mile per hour zone at night in a residential neighborhood at 60 miles per hour, and a cat runs in front of you. What do? Well, it depends on the person. Some of you guys may speed up. Some of you guys may go, okay, let's slow down. So you put the brakes on, and then it goes all the way up to the cat, over the cat, and then obviously you're going to keep skidding about 140 feet. Okay, it's not a big deal usually, and then you go, oops, I made a mistake. And most people would just keep on driving. It's not a big deal. But what if a kid runs in front of you? You don't have much of a choice. All right, so you put the brakes on, all the way up to the kid, over the kid, whatever. All right, and then the police is going to show up. Okay, so what are you going to say? Oh, gee, I was going at 60 miles per hour in a 30 mile per hour zone. The kid just came out of nowhere, unexpectedly. All right. So what are you going to do? You're just going to lie. You're going to say, you know, officer, I was going right at the speed limit. This kid came out of nowhere. I put the brakes on. You can see the skid marks just going all the way up to the kid, over the kid, and blah, it's 140 feet. What do you think they will do? The first thing that they will do is they will measure the skid marks. Okay, they will measure the skid marks. They don't care that you're driving a Ford Tempo or a motorcycle or a truck. It doesn't matter, guys. Those skid marks is all they need. If they know that you skid at 140 feet, if there's skid marks that they can measure, and they will know roughly how fast you were going. That's it. That's all they need. It doesn't matter that you're driving a Ford Tempo, Mercedes, truck, motorcycle. It makes no difference whatsoever. All right, so that's what happens. All right, so the next question is, why? Why is it that a truck and a car are moving at this, accelerating at the same rate? It's easy, guys. Take a look at the weight. Okay, so take a look at the, what is 17,000? Take a look at the net force acting on this one, and take a look at the net force acting on this one. Take a look at the mass of this one, and take a look at the mass of this one. Okay, notice that the mass of the truck is going to be, this is 100 times larger than this one is. All right, frictional force is also going to be 100 times larger. Okay, heavier something is, the more friction it's going to experience. Okay, so the weight is 10 times larger, the frictional force is going to be 10 times larger. As a result, the acceleration is going to be the same. The weight is 100 times larger, the frictional force is going to be 100 times larger. So the amount of friction that it's experiencing is proportional to the weight of the object. All right. As a result, these vehicles are going to accelerate at the same rate if they have the same initial speed. All right. It's very counterintuitive. So what that means is in terms of which one is going to come to a stop, car or the SUV, your common sense will say it's car. In reality, it should be the same. Okay, yeah, car is less massive, but the amount of friction it's experiencing is going to be less. SUV is more massive, which means that the amount of friction it's experiencing is going to be more. SUV is almost 2 times more massive than a car is, which means that the amount of friction it's experiencing is going to be 2 times as large. It's going to be 2 times larger than the frictional force that the car is experiencing. So, which means that both of them will come to
Can an SUV stop
at the same time whilst getting the same distance.
better in bad conditions than, say, a Honda Accord?
Absolutely not. In fact, even on dry pavement, an SUV takes longer to stop than an ordinary car would.
Because of the
All right, so I think this is that Dateline. I'm just gonna blame NBC for this.
way that the vehicle does.
This guy works for AAA, guys. He's no expert. He's just telling you what you will want to hear common sensically.
Take longer
All right, you should get a physicist or an engineer or someone who can explain it better than this guy. This guy doesn't know anything.
for it to stop?
Oh, yes, absolutely. The heavier the vehicle, the longer it takes to stop.
That's not true. All right, it's not his fault. It's just NBC. Just get a real expert if you're going to have a real physics question. All right, engineers and physicists can answer this question. If you're not an engineer, if you're not a physicist, only thing which is going for you is your common sense, which is no substitute for education, guys. It's not the same. All right, so having said that, go take a break for 10 and be back within 10. Instead of breaking the problem into like 1,000 different pieces, we'll just less than that do the problem. Okay, so what do I know? We got a car and we have an SUV. Okay, so we'll have the car over here and the SUV stuff is going to be right here. Okay, so the mass of the car is going to be 2,000 kilograms and the SUV is going to be 5,000 kilograms. That's it. Both of them are going at 60 miles per hour. All right, so this is 26.79 miles per hour. Both will come to a stop.
Shouldn't that be meters per second?
Meters per second.
Okay, give yourselves 5 points for that one. Absolutely correct. All right, so meters per second. All right, so the final speed is going to be 0. Okay, so what do we need? That's all the information we got, right? Oh, well, the tires are skidding in both cases, so it's going to be coefficient of friction. It's going to be 0.85. There's no, it's unitless. Okay, so there's nothing there. Okay, so A. How long does it take? Okay, so this is time, and this is how far. Okay, so for both of them, A is going to be the distance in terms of meters and maybe feet. B is the time. Okay, so I got everything listed, I think. Okay. Okay, let me go to the formulas. Just grab the relevant formulas. Anything related to force is going to cause acceleration. So those are the formulas that I will get to use. All right, so whatever it is I need, let me just put the formulas to the side. All right, so this is good. Before I attack the problem, let me do a force diagram. Makes it easier to visualize things. Okay, X and Y coordinates. Force of friction. The kinetic frictional force. This thing is going to have weight. And then there's going to be normal force. Okay, so those are the forces. This thing is moving horizontally. I'll come to a stop. Final speed is going to be 0 within this distance and within this time period. Okay, so that's it. All right, so X is what I'm looking for, assuming that the acceleration is constant. Okay, so I can either use this formula or that formula. All right, I don't know the time, so which means that this formula is not good. So this is the one that I will use to solve this problem. All right, so that's my initial formula, so I'm just going to start off with that formula. All right, so the final speed squared, initial speed squared, 2 times A times X. And what we sum for? We're sum for X. Final speed is 0. All right, so I'm rewriting the formula. Get rid of the initial speed. 2 times a times x. Okay, so let's get rid of 2 and get rid of a. Okay, so let's stop at this point. I got a number for this one. That's like still 60 miles per hour. I don't know what a is, so a is what we need to figure out. All right, so what do I know? I know that the acceleration is going to be caused by a force, net force is going to be responsible for the acceleration. And I also know that the net force is going to be related to, if you visualize it, this is the kinetic frictional force acting on it. So what that means is the net force along the x direction is going to be just the negative of the kinetic frictional force. All right, so this is going to get substituted into that. It's going to be ma, so sub for a. Okay, so I'm making it longer, but that's fine, so you can see the work. So the next thing I have to do is just substitute this in here. It's going to be 2 times the frictional force divided by m. Okay, you got a negative here, you got a negative here, so that's going to become positive. So the denominator of a denominator is going to be the numerator, so m is going to go up here. All right, so okay, so I'm going to rewrite this formula, clean it up. It's going to be mvo divided by 2 times the kinetic friction force. All right, so what do we know? We know m, which is fine. All right, so we know the m in either case, so I'm good with that. We know the initial speed, 60 miles per hour. But we don't know the frictional force, kinetic frictional force. All right, so now we have to come up with an expression for the kinetic frictional force. Okay, so once again, we will play the back substitution game. All right, what do we know? Kinetic frictional force by definition is this. Okay, we know what this is, which is 0.85, but we don't know what this is. Okay, so which means that we'll have to keep playing this game. N is unknown. We can figure out n looking at the forces on the y direction. So what do we have along the y direction? W, and it's going to be a reaction force. So look at the net force on the y direction, n is up, W is down. There's no acceleration on the y direction. So which means that the n is the same as W, W is the same as mg. Back substitution. And then we have to do a back substitution again. This is going to be mu sub k times mg. This gets substituted into that. All right, mvo divided by 2 times mu sub k mg. Okay, so one of the things that you will notice is, hopefully, masses will cancel. Mass doesn't matter in essence. The more massive it is, the larger the frictional force is. All right, so we didn't even need the mass. We kind of knew that from the previous one, but now we know for sure. This is going to be 2 times mu sub k times g. All right, so here's the final equation.
VO be squared.
Okay, I'm sorry, what you say?
Did the VO be squared?
No. Okay, let's go back. Absolutely, give yourself 2 points for that one. Okay, guys, the nice thing about showing work like this, notice that when you make a careless mistake, and if I were to grade this, obviously, if there's a careless mistake like that, you will lose only a fraction of a point, because I could see that you know what you're doing. It's just sometimes it's tough to concentrate. Okay, so everything is fairly clean. All right, now we are good.